Thank you very much for coming today. And as it is announced, we're going to conduct this session in Japanese from now on. So please turn on your receiver. ということで、日本語で
Okay, let's start the conversation in Japanese from here. Welcome to digital technology, digital twin use for the urban city resiliency, how we can leverage technology to improve the digital or urban resiliency. That's going to be the theme for today. And let's pay attention to the most recent news, just as a kickoff. On January 1st, we suffered from an earthquake in Noto area, as you can see from the screen. I belong to Yomiuri Shimbun, the newspaper. This is the contents that we built. And the earthquake took place in the afternoon on January 1st, around 4:15 p.m. And then almost nobody was there because it was a New Year holiday at our head office. But we were able to find someone who were able to create the contents and also made these contents available online as well. So on January 1st, 11 p.m., 7 hours after the earthquake, we were able to publish this contents. And you see the photos and also the location of the photo taken combined together to show the information to the public. It's not showing up on screen at the moment. It seems like finally communication is catching up. Well, disaster photos usually is shown as is, but one of the uniqueness of this time was that the location of the photo taken, the angle of the photo taken was mapped to the map itself. So all the visitors to the sites get to see how the photo was taken, and also stricken area was updated real time. This is in Noto City as in the afternoon of January 1st. This was taken as a photo, and then the reporters was on site. One person was on site as a reporter, but other medias after the earthquake couldn't come into the site. So everybody was struggling. But the fact that we were able to make this available to the public is great. Photos you see on the right-hand side, and you can immediately locate where these were on the left side. No need for programming, no need for coding to show this information. That's what's unique about this. And we were able to create this content at such short time. This is the angle and location of the photo taken. This is just an example. Professor Watanabe, our staff members studied under the leadership of Professor Watanabe, and people who are savvy on the technology and the knowledge created the contents. If you're interested, when you go home, please take a look at this contents. Recovery is ongoing in Noto area right now, but you get to see how it was on the day of the earthquake by pinpointing where this took place. This is just an example, but the question now is how these technology can be leveraged by media, how these technologies are readily available to the public. This is the conversation we would like to ask Professor Watanabe to lead. Hi everyone, my name is Watanabe. Well, as Mr. Yoshida introduced me, I would like to focus on the disaster digital map work that I've been working on and what kind of technology, what kind of people are involved to evolve this technology, something I would like to talk about. Main topic for today, as you can see, is shown as a title, Real-Time Disaster Map Projects. Last year in January, last year in February, there was an earthquake in Turkey, Syria area, and also this year in New Year, we had Noto earthquake, and then the other day we just had Taiwan earthquake. So these are the three scenarios that I would like to go through. In order for us to create map, what are the technologies that play a very important role? That's described here on the slide. First, open data satellite images and also 3D data, accessible to everyone. That's very important. And also at the same time, what's important is to offer no-code platform for everyone. Also, it has to be a good storytelling visualization for better understanding. Lastly, it's not just making the map available, but also I often use X, former Twitter, quite often to share information so that we can reach a lot of users. So through such methodologies, we can offer a rapid disaster response. At my lab, there are 4 projects that we've been focusing on and working on. The first project was on Hiroshima A-bombs survivors project. We created a digital archive back in 2011, 14 years ago. And then we moved on to the next project, tsunami disaster victims, and then moved on to the Ukraine war. And then the fourth is the fourth one shown here. And this is the Hiroshima atomic bomb archive. What we heard from them is described in 3D map. What you're looking at in front of you, this is the Hiroshima right after the war. And we kept the interview of the survivors. And the interview imagery was collected by Hiroshima high school students. And this was the project of mapping those archives with the map. And the project itself had to be done with the programming by myself, meaning it's taking a lot of time. And another important point is that, let's say if I pass away, or if I leave the university, then there's no successor for this project. That's the issue. Next is this one. Yoshida-san belongs to Yomiuri newspaper. This project is done with the collaboration with the mass media. It's called Iwate Nippo, company in Iwate. They collected the data, and we leveraged such data to focus on 2011 tsunami. I'm sure some of you might remember the visitors to Japan. Back in 2011, we suffered a very big earthquake. 20,000 people passed away because of this earthquake, and we regenerated that data. People who passed away, what was their behavior just before they died is visualized here. Again, this has to be done with my own programming to achieve this. So based upon data to create this map, it took more than 2 months. So it was a very cumbersome process. And it was back in 2016, so it was 8 years ago. Then this is about Ukraine war in 2022. It's been 2 years since this sad war started. And this project, back in Ukraine, the 3D data is being collected by creators, and this was more of collaboration with those creators who collected all these data. And Ukraine creators created 3D data themselves, and they sent those data to me so that I was able to create this 3D map myself. And the contribution factor was that no-code approach. I was able to create this map without any coding. This played a very significant role. So we received a data, creating a map. It was done within less than a day. So data was sitting on 3D map. We make it public. It's done in only a day. So now this is me answering some questions in the interview.
And today's theme, that is about disaster. Last year, it was February last year. It's been a while since then. So there was a Turkey and Syria earthquake occurred. And at that timing, the US company Maxar Technology, they fly satellites. And the images shot by the satellites were opened as a data. And that was a big point. You might be surprised to know that from Maxar Technologies, when you purchase satellite images from Maxar Technologies, it would cost millions. It is very expensive. However, at the time of disaster, all the data would be opened. However, raw data is not for the actual usage as it is. So specialists, researchers are required to open the data, first of all. So just open data would not be enough to permeate that information to many general people. So what I came up with as an idea is based on the one that I used for Ukrainian war mapping technology. So no coding, however, you can make up 3D mapping. So I thought that we can apply this technology to this case. And that is the actual process of making that mapping. This is called Cerium. I'm using Cerium stories. Cerium, that's an US company. And without programming, they can make up a 3D mapping, and that this technology is opened. The presentation next to me is Shinnosuke-san here, sitting next to me, and he is also providing a system that would allow us to make up 3D mapping without coding. And utilizing this technology, I try to make up this content. So please have a look at this. In 2023, that was February 10th, 2023, and the content was launched on that date. The data was sent to me, was opened the previous day. So Maxar Technology issued and broadcasted the satellite map on the 9th of February. And on the next day, on 10th, I was able to create this. So it's one day after open data release. So it was 3 days after the earthquake, actually. And the map was created. So what was the appearance of that? Well, what is the application? Is it like? So it was a big earthquake. So there is a big fault observed on the ground. In a satellite image, together with the specialist, I tried to analyze the scenes. Looking at the images of satellite images, the fault is as long as 100 kilometers. And what is the reason why this is available is, as I mentioned earlier, on the internet, the map creation that would be visible to everyone is available. That is the big reason. So in our research team, I needed to invite the specialist if that type of technology is not available. So we need to analyze the image, and I need to write the thesis and then make it publicized. But it will take several months. However, by making this type of map on the internet, we were able to collaborate with many of the numbers. And another case, that is also an interesting output. So you see a very high resolution picture. So the debris of the buildings by earthquake, and also the rescue teams are taking actions on the ground. And those pictures are taken by drones. We were just looking at the images from the satellite. So that would be away from the Earth's surface about tens of kilometers. However, this picture is different. You see some detailed information such as people, tents, as well as food as well. At the time, Turkey-Syria earthquake, NGO took a lot of pictures on the site by drones, and those data also offered to us. So that is why we were able to incorporate that data to this. And it took only several hours. It's around 2 to 3 hours results of collaboration. Another case, that is also a very important thing. So it is a town in Turkey. So utilizing artificial satellite, the same type of picture were taken chronologically. So after the earthquake, you can check and track how the town after the earthquake is restored. So 3D mapping as well as utilizing satellite, we are able to achieve this type of pictures. After the earthquake, people tend to forget what happened. At the time of the earthquake, many reporters gather to issue information, but after some hours, some days, you will forget about it. However, by tracking the images by the satellite pictures, you can keep your interest as well as the support from many people would be continued. And another important point. Maps need to be permeated or else you would never access those maps. So first I took a movie like this and I tried to post on the X. And this is also very important. That was actually Turkish language. I tried to write down in Turkish. Of course, I can take advantage of AI for translation. If it is written in Japanese, no Turkish people would read it. Therefore, I wrote down in Turkish on X. Then Turkish influencer retweeted my posting. And that made a lot of stories. I actually received a reporter's visit by Turkish broadcasting stations. So that is also very important. So when I make a presentation at an academia, Japanese academia, which would not be reported to the people in Turkey. However, by utilizing social media, I was able to communicate to the people in Turkey, and the Turkey people was able to take advantage of that. And this is the access record 1 week after the earthquake. And you might be surprised. So the top ranking users was the people from Turkey. So after a week of the pictures that I disclosed, 90% of the Turkey people, 90% of the total users were Turkey people. That means the information that issued was utilized by many Turkey people. So 3D data, open data were utilized, and also it posted on a social network. So through this measures, we were able to make up a convenient map that would be useful for the people on the site of the disaster. And this is a picture taken in Japan. On the 1st of January, there was a big earthquake in Japan, which surprised us. And at that timing, I also used open data. So Geographic Information Authority of Japan, GSI's information is used. And this is pictures taken by the airplanes. And utilizing the pictures from the airplanes, interestingly, you can make up a 3D data. So the ground surface pictures are taken by the airplanes in 2 angles. Then you can make up a 3D model by processing. And I use Studio Duckbill. That is a 3D computer graphic company, and I collaborated with this company and spent about 6 hours to complete the 3D map. Just remember the previous map in the case of Turkey earthquake. It took 1 day for me to complete that mapping. However, in this case, it took only 6 hours. So you see accelerated. And please look at the map. So the roads are broken as well as ports are broken, and also the landslide. So those are all visible in a 3D sense. So it is very realistic. And as for the earthquake in Noto, the roads are broken as well as ports were broken. Therefore, nobody outside can go into that site. However, those people also can take advantage of those maps. So 1 million people utilize this map to analyze the situation of that site. So that local people on the site, as well as NHK, the broadcasting station in Japan, they utilize maps so that they can take various activities for the people on the site. And that type of technology was advanced further and also have been advancing further and further. Komiya-san is going to give us presentation later. So without programming, no code, they offer technologies to make up a 3D mapping, and also 3D information-based technology is more further advanced these days. So the story I covered was a 3D mapping generation by public people, general people, and that type of technology is already available. As soon as you learn about the technology, you are able to make up such kind of 3D maps. And this is a map that I disclosed at the time of the earthquake in Taiwan, and it was very easy job. Just with smartphone and PC, you can make up this type of data.
So let me wrap up my presentation. So open data, 3D data, not only making it access public, but you also have to make sure that these data are accessible to everyone. And the no-code platform plays a very important role. And as I said, presentation based upon storytelling also is very important for better understanding. And with the power of social media, you can send out and disseminate information. Therefore, we can enable rapid disaster response. Thank you very much. Thank you. Let's move on to Watanabe Lab researcher who founded the company later named Eukarya, where they offer a product called Re-Earth. Let's hear from a developer point of view what kind of collaboration can be made in this space.
So let me introduce myself, our company in English and Japanese first, and then I'll talk in Japanese later. Okay. So my name is Shinosuke Komiya. I live in New York City right now, and then I'm a co-founder and also CDO, CSO of Eukarya. CDO stands for Chief Design Officer. So my research team is human cognitive augmentation, and I'm an alumni of Watanabe Sensei's lab in 2017. And then our company also established by the member of his lab. And then our CEO and our CTO is also the same lab member. And so we've been developing software which is called Re-Earth. And then Re-Earth is an open source WebGIS platform that allows you to visualize or analyze a data set of GIS without coding, as he mentioned. So let me introduce that part in Japanese. Okay.
Hi everyone, my name is Shinosuke Komiya. Right now I live in New York, and at Eukarya I serve as CDO, co-founder, and also CSO as well. CDO stands for Chief Design Officer. Ourselves built a program called Re-Earth. Well, it's a WebGIS platform, and anyone can make use of it without coding or programming. You can visualize, you can analyze the data. All you need is a web browser through our platform. So as Professor Watanabe mentioned, we can create contents very quickly. GIS is a Geographical Information System. Using GIS data is quite complex usually, but we can simplify this process through our platform. One of the biggest showcase we have is called Plateau View 3.0. As of this year in April, we just released this, and the Ministry of Land, Infrastructure and Transport, MLIT, has been developing and using Plateau View. Plateau project is driven by the ministry by focusing on the 3D model of all cities And the buildings have lots of metadata for each location, not only the buildings, but also roads as well. The humongous amount of metadata being managed by the ministry, and they make that publicly available. However, data is very heavy, so we offer VEarth so that you can see the information on plateau view. You can process data, you can add your own data as well. So by using plateau data, you see the metropolitan area designs, you can look at the heat map or terrain data. The 3D data is available, and you can run a disaster simulation as well. Please search Plateau View so that you can learn more about the details of what we do. And one of the theme is about the disaster prevention. On that front, what we've been doing is, this is location called Tokyo Hasuda City. This is the submerging simulation. Well, this is information captured from the Ministry of Land, Transport and Infrastructure. If you see more of a submersion happening, well, usually you see lots of evacuation areas, and the question is that from your work location or from your home, you have to think about how you evacuate from the stricken area. And by changing the time, you can guess when this water might reach you, meaning that you might lose the evacuation route if you don't evacuate within the given time minutes. Let's say with the river flooding, many locations in Japan are well managed, so you might not have to evacuate too often, but in overseas location, this is one of the major challenge. In Peru and also in Ecuador, we are also being active in those locations as well. And this is one of the example in Lima City in Peru. NGO, PEUDIS, and CRIDIS and us collaborated on the past data. Well, they own the past data as well as the actual data. There is all PDF data available. Well, when you look at the map, it doesn't move. All you see is just a static map. And the research details is something that you might have to look for. So since it's a report, and all you need is an URL, but it's not necessarily a viewer-friendly situation. So what we can do is to leverage the multimedia so that the information gets more dynamic, just so that you get to see what happens really in case of the flash floods. Well, in Peru, El Nino happens often, and the coastal area, you don't really see much of a rain. But in the mountainous area, you see lots of flash floods, and then without you knowing, sometimes you suffer from flooding, and infrastructure is not that well advanced. So once you see a flash flooding happening, then it usually leads to a flooding. So early alert is very important. Well, I'm sure there are lots of NGOs and NPO working on it, but what we can do is to offer this visualization so that all the public citizens can understand what's going on in the city. Why we chose Peru? There are lots of reasons. Of course, we certainly know, well, Peru suffers from earthquake, tsunami. So from a disaster point of view, Peru is very similar to that of Japan. So we can leverage our activities and experience and knowledge that we acquire in Japan for Peru. That's why we are quite active in Peru. This is very similar to the Tokyo example. Once you see more and more submersion, then this is more about the demo of the advancement of submerging. This is working with the Waterworks Bureau. Well, they don't have a way to make their data public, and local autonomy officials need to create their own contents. However, they don't have those skill sets. Even though they have the data, they might not have those skill sets. And usually with our open source platform, they ask us where the data is. Of course, we can make use of open data, but open data could be old sometimes, which is one of the challenge. But at the same time, There are others who might have a data, but then they might not have a way to disseminate the information. So from both sides of the aspect, there seems to be some challenges. So what we can do is for data owners, we can offer an easy plotting method. For those who don't have the data, we can generate data. Based upon the past data, we can mix and match the data for those people who don't own data. This is one of the features we can offer as part of vEarth platform. So that's it from me. Let me do a little PR here. Eukarya. We have a booth right next to Shimizu Construction. I just gave you some samples of the examples. If you're interested, please come and visit us at the booth right over there. We're also hiring people, so if you're interested, come approach us. We can speak English, we can speak Japanese, either language is okay. Back to you. Thank you. So 2 of you, stories just reminded me that the lower the technology level, that more people can take advantage of the technology. There could be more way of using that technology. So like a Turkish earthquake example, there are lots of information that you can disseminate, and there are lots of ways to apply this information. Sometimes media leverage it, government leverage those data, GIS data. Past, now, future, from those chronological perspective, how do you see the evolution of the use of the data? Let's say in my presentation, I talked about those methodologies, but this is achieved within a year or two. And I showed you the Hiroshima map for those examples. This is how we went through. Back in 2011, when we created Hiroshima map, we worked with Hiroshima City together. Map creation required lots of time and money. We had to make lots of adjustment for that. At the end of the day, sponsor finally came out. That's why we were able to make this happen.
So I gave you a lot of examples. However, even when I say that those are available, that was not very much used without that type of procedure. So what has changed so far is after Ukraine war. So one of the biggest factor of that change is, for example, looking at the satellite images. So there is a lot of, so it was a war that satellite images are utilized in many ways. That means many of the people found out the benefit of the data, open data, and also because of the advanced technology of open no-code programming, and combined with these technologies, we are able to gain this type of information. So for about the past 1 or 2 years, the technology for this purpose has dramatically changed and advanced. That is true. The first trigger for us to develop Re-Earth was I was exposed to your solution, and there has been a lot of requests on us. And I do not, rather than asking you to make up from the scratch, but everybody needs to be joined so that everybody can use the technology so that they can make their maps by themselves. So, and the reason why I make it very often is that should be available for everyone on the web. Yeah, I think he was under stress when he was in my room, because there were many people who were requesting that kind of services, and he wanted everybody should be available or feasible to make up this kind of development. Then, with his technology, more and more people became able to create such maps. And I think that type of technology would be permeated. But in order to accelerate that, what type of people as well as systems as well as platform, technological platform as well, what type of improvement would be required from your point of view? Yes. What you are looking at right now, this is also a map. So just in case that nuclear missile was dropped on the city of Tokyo, what happens? That is the scene of the map. And students of Tokyo University, not a graduate school, but the sophomore of the Tokyo University made up this type of application. At Tokyo University, what I am doing is the follows. So for the students, we let them use Re-Earth. So that was developed by Komiya-san. It's no-coding platform. And also maybe the people in the venue should know about it. So that is also GIS software called ArcGIS. So we gave lessons so that they can make up some maps utilizing such technologies. And 50 students took this course at Tokyo University this year. And what is very important is they are not graduate school students, university students. They have not decided the majors right after entering college. And as for the basic technology, we let them learn GIS technology. Then when they decided to become engineers, or when they decided to work in government, or started to work in service companies, if they have technologies about GIS technology, they can utilize their technology, engineering capability in their own places. Tokyo University is a national university, so many of them would go to a first-ranking type of companies and organizations. And in the case they become the management people in some years, if they have capability of GIS, I think that the future of Japan would be much better. So this type of representation would be available. So if we are able to see an executive of Tokyo Metropolitan Government who are capable of making up this type of visuals, I really want to see that type of people in the near future. So there can be very few people right now in Tokyo Metropolitan Government. So, but in the future, I hope we can see those many people. And also, in the near future, I think it would be possible for us to work with many of the colleagues of Yomiuri newspaper. Yeah, having heard that, I live in New York, and New York is very advanced. In the district of New York, there are some city halls, and for those people in the city halls, GIS experts are allocated to the New York city halls. I think this is not the case in Japan at all. So on the side of the business, of course, this is going to be difficult because they can use their professional tools as well, just like us. But under COVID-19, the maps of the quarantine stations was made up by the people in the city hall, and also on the road. So eating space was also generated at the time of the disaster. So where can you find out those stations, eating stations, and where can you get food? Those types of mappings are also available right after that. So New York City government offered those maps in many cases. So that is really the scheme after such experts were grown in each of the organizations. If this can happen in Japanese organizations, many things would be possible. The reason why I make this open source is that I would like to make up a community. Such kind of achievement require a lot of people as well as data, as well as the people who are capable of making that. And also we need some people on the site or those who are directly involved with that. So after the earthquake, there should be communication with the people on the site. In that sense, we need communication. So without the people on the site, their information can be not realistic, and also we might not be able to confirm whether this is fact or not. So by making up a community, variety of people can collaborate. So with a lot of data, and of course, each of the people can have some wishes, and various types of resources can be collected. And I think workers as well as the people who can collaborate in development would be very important for us. And when we actually an employee, the refugees from Syria, as well as Lebanon, and we can work remotely. So they work as engineers for us. And one of them have migrated to Japan. So that person is communicating and collaborating is a mother who has not under marriage. So there are many types of works or tasks. Even without disaster, there are many cases that map can be utilized. So the point is, how are we going to make that information useful? Okay, thank you very much. So I'd like to open the floor for Q&A. So any questions from the floor? No questions from the floor? Or yes, please. Yes, I will give you a microphone. And is this going to be? Yeah, thank you very much for your presentation. As for the assumption of such service usage, so media can be one of the examples of the users. But in the end, the usage by the public people, so of course, it would take some time until the people can receive data. But how much level are you now considering about that type of usage by the public? So is this really realistic already right now? Yeah. That technology itself is available for the public. So there is no Re-Earth website right now, but if you Google reearth.io, you can start using this technology anytime you want. What is missing right now for us is that we try to make it as easy as possible for the usage. However, it requires some level of expertise now still. Therefore, education, training, as well as input mechanism should be available. So I need to enhance that. But with some desire, of course, many people can start utilizing that. So it doesn't have to be the people from media at all, I think. In that sense, the linkage with academia like universities would be also very interesting, such as having a session for the people under open sessions, so the people with desire can have opportunities to take such lessons. At the beginning, I talked about the maps by Yomiuri newspaper. And as for the maps, I gave lessons to the reporters in Yomiuri newspaper, and those are the results of such kind of lessons. I spent 1 year for the lessons that they took. And right after the 1 year lesson was over, the maps were completed and generated and completed. So even when you are doing with university, government, and enterprise, the end purpose is to convey or distribute that to the people, public people. So there is a project called Plato by Emlet, and this is also available on the web, so everybody can utilize it. And there are some applied cases. One of the application of ours is visible right now. This is also after the earthquake, and we made up a kind of a storytelling type of application so that you can follow and track what happened in this. So it was right after the first very big earthquake in Japan, in Taisho area, which in the case of mapping, it would require a lot of actions such as scrolling and so on. But just by looking at it, you can get dynamic information. And also this is a storytelling type of information, so that kind of contents-based information to be available. And even without some expertise, you can make up such kind of stories. And this is already available. And also we are also under developing various type of such technologies. So this is also available.
Thank you very much. So things are getting simpler and simpler. So general public can also enjoy or make use of these technologies. Thank you so much for today.
Muchas gracias. Merci beaucoup.
ご登壇いただきました皆様、貴重なお話ありがとうございました。ご講談ください。ありがとうございました。Please give a round of applause to our excellent speakers. Thank you so much.